Alright, and last example here, kind of one of my favorite types of problems that you normally see in a Calc 2 course using different methods, but we can certainly talk about it in Calc 4 or Calc 3. Why not? Okay, so we want to find the area of a cardioid, and here's the equation of the cardioid in the first quadrant. So I'm talking about this space here. Okay, oh, yeah. And all of that in here. Okay, so usually in Calc 2, after you finish up in a traditional Calc 2 course, that is, after you finish up integrals, you normally talk about polar areas, and these get to be very commonplace problems, but we can talk about them here. Alright, so naturally you're looking at this and you're like, okay, there's x squared plus y squared, so that's probably going to mean that we're going to use the substitution. X is r cosine theta, and y is r sine theta, and you would be completely correct. Okay. Now the idea here is that with this change of variables, we certainly have to look at the restrictions for theta and the restrictions for r. We can do that, and what I might suggest is, well, it's probably safe to say that if we're in the first quadrant, theta is going to be between 0 and pi over 2. That's pretty safe, but we might want to check this, okay? But now at this point, what I'm actually going to do is, before we get to r, I'm going to say, well, r can't be negative, that's okay, but this upper one, we're actually going to just pause here for a moment. What I want to do now is actually play with this equation and see what this is going to give me once I do the substitution. Okay, so if I do this, let's say I get r and then minus 2, and then this is r cosine theta, and I have to square that, and this is equal to 4r squared. And I'm sorry, this is r squared. Okay, and now what I have to do is maybe square root both sides, and this is okay because we know r is a positive number, so I can do that and say r squared minus 2r cosine theta is 2r. Okay, I'm going to, let's see, divide everything by r. Okay, since r is positive, or sorry, since r is non-zero, and actually that's one assumption that I should probably make here, is just that r is non-zero. Really, r is 0 is kind of a moot point, and it's a single point discontinuity, we won't worry about it. So r minus 2 cosine theta is equal to 2, or put more simply, r is equal to 2 plus 2 cosine theta. Okay, so that's really the, when we talk about the edge here, that is the equation of this edge. Okay, so when I think about boundaries for r is going to be between 0 and 2 plus 2 cosine theta. Okay, and now you might remember that area, when we talk about area with a double integral, it's just the function is just 1. Okay, so it would be like the double integral over domain D of 1 dx dy. Okay, and so if we now do a change of variables and say this is over domain D star, okay, then we're going to get r dr d theta. Okay, again, remembering that the r comes from the Jacobian for any time you're using the polar change of variables. Okay, so then we do the double integral, and this is r dr d theta. Okay, we know theta ranges from 0 to pi over 2. Okay, and we haven't checked that, and we'll get to that in a moment. And then r ranges from 0 to 2 plus 2 cosine theta. Okay, and that's actually going to be our answer. Now, how do I know that it's 0 to pi over 2? Well, intuition, guessing. If you were to Google search me and look up and you find my U of M Twin Cities web page, there is a polar applet that I might bring up in class and show you. It's kind of cool. It'll actually compute the area of different figures that are made in polar coordinates. So besides that, what you could do is plot a few points, mainly figure out or try and find the values for those endpoints, and know that maybe take a few values in between here and just make sure that you're parameterizing the correct way. That would be kind of how I would suggest checking your bounds for theta. But other than that, that kind of concludes this video.